Well, good evening, everyone. Thank you so much for coming out this evening. I'm Andrew Petter, president of Simon Fraser University. And let me begin by acknowledging the Semiahmoo, the Kwantlen, the Katzie, the Coquitlam, the Kukite, and Tawasin First Nations on whose unceded ancestral lands we're privileged to gather, and introduce Elder Margaret, who's going to bring us greetings on behalf of the Coast Salish peoples. Elder Margaret.
Thanks, Andrew, for mentioning all those reserves. I'll never remember them. So, thank you for coming. SFOU always has exciting events, and this is another one. I was at one earlier today. So, welcome to the territory of the nations here, and just a quick prayer, and we'll get on with our evening. Great Spirit, thank you for bringing us together. Just guide each and every one of us on the path that we're on, taking care of our families while we're away from home. And bless each and every one of you for taking the time to be here, all my relations.
Aichka, thank you very much, Elder Margaret. Elder Margaret's an elder in SFU's Elders Program, and we really appreciate your coming and bringing those words of greeting. Well, this is exciting because not only is this year's Surrey President's Faculty Lecture in a series that began a number of years ago, but this is the first time we have held this lecture in this new facility of ours in the Surrey campus. Designed by Bing Tom, the famous architect, one of the last buildings he designed before he passed away. And you can see his artistry and his inspiration and creativity in this facility. So it's really exciting for me and hopefully for you to be able to enjoy this new building and this facility and to be able to use it to hold the President's Faculty Lecture Series. This lecture series is part of SFU Public Square. SFU Public Square is a program we started when we made it our commitment and our vision to be Canada's most community-engaged research university. And I would say the Surrey campus really exemplifies that commitment to community engagement in so many ways. But this new building is going to help us to amplify that commitment to community engagement because we'll be able to host events like this. And of course, because of its size, we'll be able to host even larger events in which the public can benefit from Simon Fraser, the programs, and the people that we can bring to the table to meet and connect with you. I also want to tell you that tonight's event will be filmed so we can share the lecture online. So if you do ask a question later on, you may end up on camera. Whether that's a positive or a negative, you'll have to decide. But I do want you to be aware that we will be filming and try to capture people, and certainly make sure that people who are asking questions are mic'd so that your question can be heard by those who are watching in later on our website. Well, now it's my pleasure to introduce Dr. Faranak Farzan. Faranak's innovative research focuses on what could arguably be termed the most pressing issue facing younger Canadians today, and that's the issue of addiction and mental health. According to the Centre for Addiction and Mental Health, mental illness is a leading cause of disability in this country. Its economic cost to Canada, including healthcare costs, lost productivity, and reductions in health-related quality of life, are estimated at a staggering $51 billion per year. And that's where Faranak's groundbreaking research comes in. Her pioneering eBrain lab uses a transdisciplinary approach to diagnose and treat youth mental health and addiction by developing innovative solutions that combine artificial intelligence and technology with non-pharmacological treatments such as cognitive brain therapy. Faranak holds the endowed chair in technology innovations for youth addiction recovery and mental health at SFU's School of Mechatronic Systems Engineering, which is based right here in our Surrey campus, in fact, one of the signature programs of this campus. She is an amazing academic. You're very lucky to be able to hear her this evening. She's authored over 70 peer-reviewed journal articles. Her work has received funding from prestigious agencies nationally and globally. She's also the founder and scientific director of the Center for Engineering-Led Brain Research, or the eBrain Lab that I mentioned earlier. The eBrain Lab, together with 4D Labs and our Big Data Hub and Image Tech Lab, are part of SFU's exciting new core facilities program, which we launched just late last year. In addition to her many impressive academic credentials garnered from McMaster University and the University of Toronto, Faranak also undertook postdoctoral training in cognitive neurology at the Harvard Medical School. So please join with me and join me in giving a very warm SFU Surrey welcome to Dr. Faranak Farzan.
All right, good evening, everyone. I'm very excited to share this evening with every one of you, and thank you for taking the time to, away from your family maybe, to be here with us today. And I want to also especially thank President Andrew Petter for putting together this lecture series to begin with, and also for giving me the opportunity to speak to you about some of the work we do here in Surrey by combining several fields of research, as you can see, neuroscience and engineering, to tackle a very important issue in our society and our community. Now, to begin with, I would like us to do an activity together, and I'm going to join you in this activity. So I want you all to think about names of 5 people in your life who are very dear to you and you care very deeply about. I want you to think about them, think about their names, and imagine their faces. Take your time. There is no shame in choosing yourself to be one of these individuals. That's quite fair, and we should all love ourselves. But I want you to choose their names and think about their names and their face under those little icons over there on the slides. And I'm going to give everybody 20 seconds to do that. All right, I hope you all did that exercise. Now, I have to tell you a story now about one of these individuals. Just by statistics, one of these individuals is very likely to be impacted by a mental illness in their life. These are just numbers, and they do not lie. And we need to face them. So what are we going to do about this? So what is it going to happen to this very loved one in our life, who's going to be in our life maybe for a long time? Maybe it's your child, maybe it's your partner, maybe it's your friend, maybe it's your neighbor. 1 in 5 is a big statistics here. Now, again, by statistics, just by numbers, the chances are that this individual, our loved one, is going to be more likely impacted by one of the 2 most common mental illnesses. That is depression and anxiety. And what does that look like? Is that they're going to feel persistent feeling of sadness and loss of interest in daily activities, or they're going to have excessive and persistent worry and fear in their lives. So this is potentially something that one of your loved ones is going to deal with. The story doesn't end there. Now, unfortunately, our loved ones who are impacted by depression or anxiety are at much higher risk of engaging in substance abuse. In fact, out of the 3 individuals who are impacted by depression or anxiety, 1 of them is going to engage in substance abuse, which is something that here in Surrey we see quite a lot. And again, it does not end there. For that individual, there is a 50% increase of chance of them engaging in suicide ideation, thinking about ending their own lives. So one of those, every 2 of individuals impacted by depression or anxiety think about committing and ending their own lives. This is obviously horrible, and we do not want that for our loved ones to go through that. And unfortunately, suicide remains to be the 2nd leading cause of death in our youth. And this is particularly important for us in Suri, where we have one of the highest population of youth in the region. Now, assuming that we care so much about this individual, we're going to help them to find a treatment. The good news is that when it comes to depression and anxiety, there are a host of available medications and cognitive behavioral therapies outside that you can tap into. Well, what is the challenge? So let me show you what it's going to look like for this loved one of us who's going to go through identifying a treatment that works for them. So they're probably going to start by thinking they should go and see a counseling service or someone to talk to understand what's happening. Maybe you encourage them to go to that person or to a family doctor to speak about their symptoms. Now, the chances are, unless they're extremely lucky, very, very lucky, the chances are the majority of people would not start feeling any better after their first treatment approach. And time starts ticking, and still they're suffering from a lot of untreated symptoms. They perhaps start checking out a different approach. Maybe they try to go see another therapist, maybe this time a psychologist who's going to speak to them about their symptoms and try to identify what the source of their problem can be. Again, months may pass by, weeks may pass by, and that may not be the solution for them. Now, next, so they may say that, okay, a doctor may prescribe some sort of a medication out of the 30 medications that are possibly available for depression, and you'd hope that this one is going to be the one that works, and you're all excited now. I'm afraid to tell you the chances are even that may not be the one that they need. They're gonna go on and try another one. Is that gonna work? What do you think? Probably not. Maybe the side effects were not tolerable enough for them, and it was not worth the positive effects. This is gonna continue. This is gonna continue. Is that the good treatment? Possibly not. Is that gonna work? Possibly not. Maybe it was an 18-year-old son that you had. Now it's turning into 24 years old. Maybe now they have to change from seeing a child psychiatrist to being seen by adult psychiatrists. Now maybe they move. Maybe they move and go to another university, to another place. And again, they change doctors and nothing is working. So I think you're beginning to see the picture here. And this is the most annoying slide I have here to show you today. That we're trying everything and nothing is working and clock is ticking, and our life is just passing by. And these are months and weeks and years away from work, from school. You as a loved one taking care of them, taking care of yourself if you're the one affected. Until one day, finally, a treatment may work. A treatment, it could be a medication, it could be a cognitive behavioral therapy. You finally found the one. So you finally relieved that something worked. And you're all happy now. Now, unfortunately, even though this is true for half of people who are impacted by depression or anxiety, unfortunately, not everybody responds to any treatment. And what that means is that for the second part of the population, in fact, nothing works. They go through that exercise of identifying an approach or a treatment that works for them, but up to 50% of them may not respond to anything available out there. And this is particularly true of youth, in whom sometimes medications even have side effects. In fact, FDA has put a black label warning on some of medications indicating that if someone is younger than 25 years of age, may experience suicide ideation if they take certain antidepressants. So a lot of our youth may even refuse to take medications, in part because they're afraid of the side effects. Now, so what happens to our loved one if they belong to this category? They're going to, in case that they're experiencing severe symptoms of depression, they may be prescribed electroconvulsive therapy, which remains to be the most effective treatment for depression, which is in its severe form. And you might be introduced to it through media, which has not done a service, but it's highly effective. It involves utilizing seizure to create an antidepressant effect. It has some side effects in some individuals, and because of that, it does not get prescribed as often, particularly to youth. And what happens is that only 1% of individuals who need it end up receiving it. So our loved one, if he did not or she did not, or if they did not answer to any of the treatments or refuse to take them, they join a population of 100 million, what we call them treatment-resistant conditions or depression. They need help. So obviously for these individuals now, there's really no treatment that sits in between those two extremes. So how do we solve that? And this is particularly very important for us in Surrey, in Lower Mainland, where we house one of the highest youth population, and we need to identify these alternative treatments for our youth. So really, we need to find a solution. One, to reduce the burden, the trial and error approach that goes into identifying the right treatment for individuals. And we need to identify treatments that actually work for those who do not respond to anything. And obviously, this problem is still there and it has not been solved. So we need a new way to approach things. And this is where I argue with several other colleagues and clinicians and collaborators that I think a transdisciplinary approach is something that's going to help us to mind the gap and start being creative and innovative to solve this, to come up with innovative solutions. And here is where Center for Engineering-Led Brain Research comes about. Thanks to Simon Fraser University for supporting the vision, and many partners and funding agencies who have recognized the vision of bringing engineering and neuroscience together to tackle this issue. And I encourage you guys to reach out to me if you would like to have a tour of the facility, and we are very welcome to receive you next to Surrey Memorial Hospital. So ever since its conception, I have been able to recruit quite a few talents, some of which are in the room today, and I'm looking at them, and they come from quite a diverse cultural and educational background. Scientists, computer scientists, engineers, psychologists, neuroscientists, so they come from all walks of life, and they all work on identifying novel treatment and diagnostic solutions for mental health and addiction. At eBrain Center, we have 3 lines of work. We develop technologies. We use our technologies to identify, to look at how the brain works and what is a measure of a healthy brain. And then we take all that and we develop diagnostic and treatment technologies and modalities for our patients and our community. So throughout this talk, I'm going to walk you through a couple of studies that we have done to in part address the 2 major issues that I just highlighted around the trial and error approach in identifying treatments and lack of treatments. So first, I will walk you through how we develop a new treatment for youth failing other treatments. I start off by technology. When it comes to technology at eBrain Center, we combined several modalities of technologies. For people in this room, if you've watched TV and Netflix and things like that, you probably have already seen what a neuroimaging facility or technology looks like. It's this bed-looking giant apparatus where you go inside and it takes pictures of your brain. So I'm going to spare you from that and focus more on another technology here which may be less familiar to you. And it falls under a class called neuromodulation technologies. As the name probably implies, it means it's a technology that allows us to interfere and modify the functions of the nervous system. That's what neuromodulation means. And it looks something like that. So this is in fact our center at eBrain Center. That's me holding what is called a transcranial magnetic stimulation coil, which comprised of rounds of copper wire, and is held against the head of your participant. So here, and you see the cameras that are following the participant in space, and when we have the image of the participant brain, we can actually track it in space and see where the head is and where every part of the brain is at. And here, is the device that delivers the stimulation to a brain region. Now, I'm going to refer to this technology from now on as TMS for short. So if it pops out here and there, I want you to remember the name, TMS. And how it works really, and I will go over this very quickly, the science behind it, is that we run intense pulses of current through this coil that creates a time-varying magnetic field. This time-varying magnetic field creates a field inside the brain tissue, which is very conductive. And if I place this over a part of my brain that is responsible for moving my hand, I can actually stimulate and move my thumb, or my index finger, or my third finger. So it actually has quite a bit of a resolution. And you may ask, what's the point of that? So if I do that, I'm able to quantify, for instance, how long it takes for the signal to travel to my hand. Are my neurons healthy? Or where are things in my brain? And I can quantify that and study the brain circuitry and network. Now, I thought to choose a video for you to make it a little bit more visual so that you see how it works in action. So I found something on BBC. Some of you may be following Michael Mosley from BBC4. So he actually visited in UK a lab that has a TMS machine, and he's going through the experience. So this is to highlight also how non-invasive this technology is, and any person can receive it, really. So bear with me with this video.
If we start at the back of the brain, we've switched off my visual cortex, so made me unable to see things. If we move a little bit forward in the brain, we've interfered with people's ability and my ability to see faces. A little bit further forward, we've interfered with the ability to perform actions. Start moving your finger.
It's quite odd.
It's not your finger anymore.
It's not my finger anymore.
We've interfered with the ability to compute with numbers.
6, 7, 8.
Okay.
Ooh, yeah. Yes.
We've interfered with the ability to speak.
London Bridge, London Bridge, London Bridge is falling down.
You think of something you can do, and we've basically interfered with it with this machine.
2, 3, 4, 5, 6, 7, 8, 9.
So what's the problem?
I don't know.
All right, so what you just saw there is TMS interfering with the brain function. So if you apply TMS for just single pulses, you're able to get a reaction from the brain. And if you now get creative and create repetitive pulses of TMS, you can actually interfere, lower down, increase, or decrease the activity of the brain region that you stimulated. Now, obviously, Michael is going to get out of that room and go and do his other things in his life and enjoy being a radio host or a TV host. So nothing is going to change about him. And this is why it's also very powerful, that it's non-invasive. Your brain goes back to its original function pretty much immediately after. Now, what is interesting about TMS is that for therapeutic purposes, if I continue delivering these pulses persistently over days, or maybe for a full month, that's when I can begin to change the functions of the brain, because our brain is plastic and it starts learning how to modify itself. Pretty much like when you go to the gym and you work out that muscle, you're able to kind of change the body mass of your muscle. So it pretty much works the same way. So it's not to be scared of the device, but to know that when we operated within the safety guidelines, it actually gives us a lot of capacity to look at the health of the brain circuitry and also understand what parts of the brain are responsible for what function. Now, there is a missing part here though. So it's all awesome having that coil going around and looking at different brain function, but we need to have a readout from the brain. If the brain region we're stimulating does not lead to a motor movement, or if it's not responsible for language, how are we going to quantify its response? And by virtue of that, how are we going to study if it's healthy or not? So this is what my lab has done for the past decade or so, trying to combine TMS and imaging with a technology that it falls under the category of electrophysiology technologies, and we call it electroencephalography. And it involves recording the signals from the brain by placing sensors carefully over different regions of the brain. And this figure is highlighting all kinds of electroencephalography devices that are available out there. Now, what is neat about this technology is that the readout from the technology, which we call it electroencephalography recording or electroencephalogram, allows us to look at the response of particular parts of the brain, look at how different parts of the brain talk to each other, and we can even look at the global activity of the brain and how things are changing globally. So, and it's pretty neat. It's not an easy thing to do. It takes neuroscientists, engineers, and students in the lab who look at the signals and identify novel algorithms to make sense of these things and their relation to behavior, but that's something that we've been doing over the past decade. Now, coming forward today, we were able to combine all these technologies together to harness the power of all of them. The TMS with imaging, where you get the pictures of where things are, and the brain recording, where you actually listen to the firing and the activity of your cells and neurons. And the apparatus looks something like that, which is kind of like what the movie you saw, with the exception that now there are sensors all around in the brain. And this apparatus has been, in the past 10 years or so, or even more, has received a lot of interest by the scientific community, to the point that I get invitation pretty much every 6 months for a lab for me to go and set it up for them. We recently set one up in France. I give teachings at Harvard Medical School for people who want to set up their own lab. And it's not only being used for us to study the brain, necessarily mental health condition, but it's also being expanded out to be used elsewhere. And our group has been the first group that has released a TMS EEG toolbox and made it publicly free and available for other centers who want to use it, to be able to use this technology to map out the brain, as I just showed you. And these are all the students who have helped with that, and you can maybe find Benjamin in the team who is leading this toolbox here. Now, you may ask, okay, this is all awesome, but this is all technology. How does that relate to actually making people better? So here is where the fun part starts. Now that we've got the technology together, we can start actually looking at how healthy the brain circuitries are. Now, as I told you before, I can give 1 pulse, 2 pulses, or multiple pattern of pulses to the brain and measure the EEG activity and start looking at excitation, inhibition, and the plasticity of the brain. And these terminologies are processes in the brain that are very important for everyday functioning, cognitive functioning, emotional processing, and all these things. And over the years, we have started growing pools of brain health biosignatures or signature markers that allow us to look at, again, how the left side of the brain talks to the right side of the brain, how one area is activated when, for instance, you're engaging in certain cognitive tasks or you're at rest. And this has really allowed us to get a fundamental understanding of these processes in awake humans, healthy humans, while they're sitting there at rest. Not in mice, not in animals, but actually in humans, which is something rather extraordinary. A lot of our neuroscience findings and results go back to animal studies or studying the brain in a petri dish. And this technology has allowed us to get out and actually test things in awake humans. Now, how did we go from there now to understand what might be going on in the brain of a youth who has depression and who's not responding to treatments that exist, and how we can then harness that to actually treat it? So what we did, we recruited, so we're getting to the part of actually looking at the brain in youth. We recruited 45 youth who had depression and who were not responsive to other treatments, or they were refusing to receive other treatments, but they wanted to be helped. And we scanned their brain and identified all the images and where all the brain networks in the brain are and all the regions in the brain are. And then we went around, just like how I showed you in the video, with single pulses of TMS and stimulated all those major nodes that we know through literature and through prior work that might be potentially impacted in these individuals. And I'm going to show you some videos here of how, so the video essentially shows a head with the nose on top and the ears on the side, and the colors are showing the activity, the network activity of the brain right after the TMS pulse in that brain region. So we went around and mapped the brain for the left prefrontal area, which is right here, for the right prefrontal area, which is there, the motor area, which is responsible for movement, and the parietal area in the back of the brain, which is also important in several cognition and spatial planning. Now, we ask ourselves, now if we compare all this, are we going to be able to see what's going on? And what we did then, we recruited another batch of healthy youth who were not impacted by depression, and then we compare the network activity between the two groups. So now you may ask, the million-dollar question is, did you find anything? Was there anything there? And yes, the answer is a big yes, and kind of surprising because the effect was very strong. And we found a very hyper-connected, and by hyper I mean an area of the brain here on the right side of your frontal area, in youth with depression was highly connected with the rest of the brain, overly connected. You can think of it in analogy like you're driving in rush hour and there is too much cars maybe going toward your home, and you kind of want to decongest that. So this is what we found, and if I plot the scatter plots for you, which is what scientists like to do, these box plots, we call it, really differentiates the groups of healthies from the group that had depression. And the further apart the scatters are, it means the more differentiation they have. And we really identify this to be localized to pretty much the right part of the brain with a little bit of also implication to the left. So how do we go from here? So this is an exciting finding, never been shown before. This has never been applied to youth this age, 16 to 24 years of age, and has never this comparison been done, and we're very excited about this. Now we want to take this further. We're asking ourselves now, can we use the same device that I showed you and apply multiple pulses to try to change this hyperconnection, this overconnectivity, and try to normalize it? And by doing so, can we change symptoms? And this is the study we've done, and I'll show you how that looks like. So we managed to get some funding from various sources to start this treatment. And here, in this slide, I'm thanking all the collaborators who joined in, and it's a multi-center approach and multi-collaborator approach to this. Mayo Clinic, University of Toronto, John Wolkin, CAMH, and I was the leader of all that. We managed to start a clinical trial to look at, for the first time, if we could apply a very brief form of brain stimulation patterns, which we call theta burst stimulation, to the brain areas that I just showed you were different in youth with depression. So what we did, we applied this pattern that has been shown through fundamental research studies that can bring down the activity of brain regions and calm down the brain, if we can use that analogy. And we use the counterpart on the other side to help more the right side of the brain. Now, this is the first time doing this, so we were cautious. We say we're going to do this every day for only 2 weeks for now, and just to see how we're going to change the severity of depression in these youth. So I'm going to show you some data here, and I explain you what this means. So here on the y-axis there, you see the severity of depression. So I'm going to color-code it for you so it's kind of easier to understand what's happening. So the red means they are severely ill and the depressive symptoms are strong. And as you come down, the symptoms are getting better. Here, before treatment, is when they were severely ill and they decided to take part in our study. So they're doing pretty poorly as much as the severity scale shows. And here is after 5 days of receiving that treatment every day. Now, this is only 10 minutes of treatment. They come in, some of them were high school kids. They would come in, sometimes with their parents, receive it for 10 minutes. We do some also assessment to see how their brain is changing, and they go back to school or they go back. So it's pretty non-invasive that way. There's no need for them to rest or spend any extra time in our lab. So after 5 sessions, you can see that already some of them are becoming symptom-free. And this is just 2 weeks. 5 days. And then by 10 days, we have managed to put pretty much, with the exception of one person, down from the severe depression to a lot more. So this is folks who did not respond to anything in the past. The drugs didn't work, the behavioral therapy didn't work, and for some of them, it was really life-changing. So now this was just feasibility. So we wanted to make sure it's safe to do this in this population, and that it is not causing them any risk, and there was no risk. So for the next study, we went a little bit more into how many sessions we offer them, and we did 4 weeks. So now they come in 5 days a week, 10 minutes of doing TMS, and they do some cognitive therapy right after. And look at what happened now. So now we have about 27 patients in this model. So they're all starting quite severe. And look at the trend. So here we're making, after 20 sessions, quite a few of them symptom-free. So now they no longer have depression. This is quite an achievement for a group of people who have not responded to any other treatments. So we're very excited about this. So as the next step that you might ask, it may come in the question and answer period, is how does this work relative to placebo? How does this work relative to other things? And we have just received funding to do that, and we will be launching that study here at eBrain Lab very shortly. And hopefully, by running that trial, we'll be able to go and showcase the results and receive hopefully some support from our health authorities around the support for this type of treatments for youth. So I just showed you some of our work where we can identify new treatments for individuals who potentially do not respond to any other treatment. But we still have to go cater to the other half who are spending years, maybe, and months and years not getting treated. So how are we going to do about that? So that calls also for some action. And now we got TMS added to that. So how do we know who's going to be a good responder to TMS, or who's going to be a good responder to cognitive behavioral therapy? So we need to now focus on this problem. And I show you now some of the work we've done in the lab to do that work. So this also calls for quite a bit of a transdisciplinary approach in which we need to use technology and our knowledge of how the brain works combined with clinical research to drive the work. And for that work, we had to also tap into our more nationwide network. So the work that I'm going to present to you is part of the Canadian Biomarker Integration Network in Depression, CANBINE in short, which consists of clinicians, neuroscientists, and patient advisory groups from all over Canada. And we come together and we solve problems such as the one that I proposed to you. And we've been together since quite a while now. And SFU and eBrain Lab represents the EEG, or the technology that I showed you that allowed to record brain activity. We are the EEG lead of this network. And this network consists of 12 universities and 16 health science centers that work together to solve these challenges. So what do we do at CANBINE is pretty much what I showed you in a small scale with what I showed with the youth trial. We go out, and my slides are changing on their own. There's a ghost in this room, maybe. And we use the technologies that I showed you, and we study people as they receive different kinds of treatments. And we do that across all Canada, and we get all the data. And all the brain data comes to us, and we try to say, okay, can we use this data to predict who is going to respond to what? And we're doing that for all kinds of antidepressant treatments, not just for medications or just for TMS, for everything, so that we can, with more certainty, be able to now assign patients to the right treatment. And as an example, and given that we don't have too much time today, I will give you an example of one of our studies that we recently have done with medications. How does that work? We started collecting EEG across several centers in Canada in a standardized fashion. And all the data came to eBrain Lab at SFU. And recall that I showed you that with electroencephalography, we can get all these waveforms from all over the brain. And it's rich with information about how the brain functions. So we take all that information and we have some know-how of where to look for when it comes to depression. And our lovely students and trainees, some of which are in the room, use machine learning and ask the question, can we use the brain data before patients started treatment? So now, mind you, how does this look like? They put a sensor hat on, they're just sitting there, there's no TMS now, it's just EEG by itself, and we just record it. And they go on to receive treatment, and the treatment goes on for about 8 weeks. Now, at 8 weeks, so 2 months later, they're gonna see a psychiatrist or a study research coordinator who's gonna reassess their symptoms and look to see whether they got better or not. If they have not got better, they're gonna switch them or give them another treatment, add another treatment to it. And if they've got better, if they're 50%, let's say, better, clinically, they're going to continue them on that medication. So the question is, can we save, as a baby step here, can we save 2 months of an individual's life and predict how they're gonna respond just at the baseline? You with me? So what do we find? Yes, we find that by 82% accuracy, the EEG is gonna allow us to actually predict whether someone is going to respond to a treatment or not. So how is that useful? So it's very useful because next time you go to a doctor, and as we grow our study to include more and more medications and cognitive behavioral therapy and all that modalities, the doctor is gonna look at hopefully a chart and say, okay, I think with 80% accuracy, you're gonna respond to this treatment. Are you happy with this treatment? It's gonna have this kind of side effects. But with 60% accuracy, maybe you're gonna respond to this one. And you help the doctors to make that decision-making a little bit more informed with the patient and the doctor present. So it's just to be mindful that we're not suggesting the computer to do everything here, which sometimes is the fear. So this work actually is the first study that's been published of this scale, showing this work, and has been highlighted in several news media recently. In fact, since it got published January 3rd, 2020, I've been receiving a lot of media calls too. So which shows also how hungry we all are for something like that that can assist our loved ones and ourselves sometimes to maneuver the pathway of finding the right treatment. So what's the future looking like? So we're at eBrain Lab, and with our funding that we have actually captured from many agencies, we're going to expand our exercise here and to include more treatments in our portfolio. All right, so getting to the last part. So obviously you say, okay, so these are all great, but how does this apply to my loved one that we just talked about at the beginning? How far are we from implementing this? And this is where here, being the Engage University, we would like to also think about scale up and scale out when it comes to our research finding and the real world impact that it has. So what are we doing about that? So we're going around and partnering with several key partners from the community, from industry partners and non-for-profits, and based on our research findings, we're co-developing technologies for the individuals. So for instance, we have biosignatures that we have identified that are highly linked with how a one-on-one behavioral therapy works. Based on that, we're building computerized cognitive training that hopefully would reduce the burden maybe on what is one-on-one therapy is gonna look like. Or we're going to use virtual reality in order to make some of these trainings more online and available. And we're also making these portable EEG technologies that are now able to be scaled up to be included in family practices and clinics so that people can be followed up. So we have several projects going on with industry and with our community partners, and we're creating the technology together. Here is a proof of that, a picture of that, in which with some of the students and industry partners, we're inside John Vulcan Academy here in Surrey testing out a technology, which is a portable technology that we're using as patients are going through a computerized training. And some of the students here in the room are conducting that trial, and they can speak to that if you guys approach them. And when it comes to portable EEG, we have started, again, one of the first kind and one of its first scale of study where we are putting portable EEG now out into several research institutes, and Benjamin is leading that work, and we are in a standardized fashion collecting EEG data now, not necessarily in a lab, but anywhere that the patients are available to be tested as they go through our research trials. Finally, I began by showing you the fancy brain mapping technology that we are developing in order to look at how brain circuitries actually work. So we are also, for the future work, expanding that work, working with neurosurgeons who actually have also access to data that is directly recorded from the surface of the brain. And we have students who collaborate with them. And we have several institutes that we are working with in order to expand the sophistication and the precision of our brain mapping technologies at eBrain Lab. Now I started this talk by bringing your attention to whoever that loved one was that you chose on the slide. And I provided you some sad statistics about that individual. Now I hope that some of the results and some of the research work that I showed you that we engaged in Suri will also make us be hopeful for the future of this person. And I firmly believe that the direction we're taking by bringing several research platforms and disciplines together, we're really creating a much more hopeful future for those of us who may be impacted by mental health. Now, last but not least, I would like to acknowledge Simon Fraser University for allowing me to do this work, my home school, Mechatronic Systems Engineering, City of Surrey, John Wilkin Academy, and all the other Digital Health Circle, and all the other funding agencies who have really contributed funding and support for all of this work to happen, and all the international collaboration. And I would like to thank you also all for taking the time to be here. I hope I did not make it too scientific, and you were able to get pieces and bits here and there. But if there are parts that were not clear, I think it's time that we can have some questions and answers from the crowd.
Well, I think from that response, you can tell there's a lot of interest and appreciation. I often get asked, what do you mean when you say Simon Fraser University is involved in cutting-edge research? Well, now you know what I mean. Using technology to better understand the brain, to provide treatments, to guide us in which treatments are most effective. Very exciting stuff in a very important area. So we do have some time for some questions, and we have a couple of microphones that can come around to help you to ask those questions or offer comments. So I'll throw it open to whoever would like to go first. Back over here.
Hi, very impressive talk. Thank you very much. I would like to ask you, what is your vision on how this kind of work is already modifying the community in Surrey, and how those different partners, which are coming from different stakeholder groups, is actually getting together toward this great accomplishment that you're showing in your talk?
Want to use this over here?
Okay, perfect. So as you can see already, so we have established the eBrain Lab at Surrey Memorial Hospital. And so just actually 1 week ago, I was at the City of Surrey being part of a group that are helping with the addiction crisis that we have, the substance abuse crisis that we have in the city. And I just told them about how awesome it is, the work we're doing, and they were super excited by being engaged. And I already got lined up several meetings to meet with them, and they were very excited for participating in this, and particularly the part that connects with developing technologies with the community is of huge appeal for the community, from what I understand. And it's exciting for us to bring some of this work that we do at the national level to more locally and build technologies. And we're very synergic with several other initiatives that are happening at SFU. So for instance, the Digital Health Circle is bringing technologies and bringing industries to the university and to the academics. So we have been able to really leverage that and use some of that opportunity to scale up our solutions. There's image tech, which is right next door, and we're able to, and it's very rare that you get a facility that is dedicated for research, an imaging facility. I've been in several universities across the globe, U of T, Harvard, and there's always fight over who can, that 1 hour of MRI scan you can have to do research, and it's fantastic for what SFU has done in contributing and really supporting the neuroscience initiative and all that, so that we can actually be able to do our work without thinking about, okay, when can we scan our patients? So that really helps us to do a lot of great work.
I think you have a lot of other things to think about, so I'm glad you don't have to think about that. But yeah, we have another question back over here. Arnab, if you want to.
I got 2 questions. The first is, what's like the referral process? Like if we want to refer like some youth that we're working with, can we do that?
Yes. So this is a very, we're starting this study soon. So there would be flyers and they would be things that you probably can see, but you can also leave your name with me, and if you want, I can connect with you after. But there would be advertisements that goes out, and maybe we put it on our website, so that way would be easy way for people who are interested to come through.
And then the second question I had was, so like did the depression anxiety like stay away after the treatment? Like was it like a permanent effect, or was it more so like or do you have to continue treatment eventually again?
Yeah, that's a good question. So it's very personalized. So I think something that we need to all appreciate, and this is in part why there are so many treatments, and not every one of them is the treatment. There's no magic bullet or magic answer. So we're all individual, and we all have our unique brain signatures. So some individuals would receive 4 weeks of treatment, and off they go. They're good. But some of them, they need what we call booster treatment. So they need to go every so often to receive another treatment. So it's very, so one of the things that we're doing a lot, and in part what the portable technology is helping us to do, the wearable technologies, is to monitor people and hopefully be able to tell them, hey, look, maybe you need to go back, right, for a booster treatment before things get out of control. So this is a direction that is also some of the work we do. In part depends on how well we can advance the security of monitoring people sort of in a seamless way that doesn't interfere with their life, but also it's smart enough to let them know way in advance that they need to come in. Does that answer your question? Yeah.
I think there was someone right down here. Get a microphone's gone its way. Go right ahead.
Hi. Oh, thanks. That was a really great overview. I was curious about the, you made a point of showing how there was no real permanent effect on people when you did it, but then I guess you're trying to show permanent effect, and I wasn't clear on what permanent change actually happens, and you'd mentioned something about cluster coherence being different, but then you didn't say whether that changed or not.
Right,
and
right.
I was curious also, how do you separate, you said they were followed by cognitive behavioral therapy, so how do you separate out the brain stimulation, which has no permanent effect, from the cognitive behavioral therapy, which is shown to work?
Right, yeah, so 2 questions there, right? So one is that what does actually change after they receive treatment? I'm not showing it here, but believe me, things do change. For simplicity, I did not make it to the slides, but there are things that do change in the brain. It does not fully normalize to what a healthy youth brain look like, but there are markers that do change after they go through the treatment. Now, how long do they stay changed for? So then it goes back to the other question. We need to follow them up and see for how long these changes do persist over time. Now, to the second point, so obviously these individuals are being followed over time, right? Some of them are doing the cognitive behavioral therapy, but something I failed to mention is that they actually did one active cognitive behavioral therapy and sham cognitive behavioral therapy. But for us to really be able to tell how much of that is linked to the treatment they're receiving and how much is that is linked to just getting better for reasons outside even the treatment we're doing, we need to do the placebo-controlled trial. And that is the trial. So they just completely receive the inactive treatment, the placebo or sham, and we compare and we follow the same way and we compare the two groups. And that's the work that we have received funding from the federal government through CIHR, and we'll be doing it in Surrey. And that would hopefully answer your question in the next trial. Maybe 3 years from now, another presidential lecture series.
A question right over here.
Actually, this probably is timely because you just mentioned you want to do a placebo randomized trial. And I'm assuming that's a phase 3 and that you've got the one center at Surrey Memorial. Is it going to go across the country? And do you already have the protocol in hand? And what investigators will be involved in it so that if we have loved ones who might be able to be considered for the study, how do we go about getting into it?
Right. So we have just received the funding, and we're about to set up all the logistics. So it's a one-center study, and it's in Surrey.
So it's not going to be like 300 patients then?
It's no, but it's large enough sample. It's about 180, I believe, or 45 in each group. So about 90 patients we're recruiting.
On each arm?
On each arm, right.
And you're not going to have a CBT arm?
No CBT arm. So that requires, so this is where, yes, so we're doing our best. We're applying for a lot of funding. So we have a lot of proposal in place right now with different agencies, crossing our fingers that if they're able to also do the one with the cognitive therapy, I think that would be fantastic. But they're expensive trials.
Right.
So we kind of have to choose which one we do.
Do you have a contract organization to run it for you?
Do we have
a contract organization to run it for you? Because it's going to be pretty complex.
No, we're going to
do it yourself?
Do it here.
Good for you.
Yeah,
okay.
yeah. This just like how we've done it with the other two trials. So we're going to try to do it here. It's with collaboration. I'm not the only one. So as you saw, there are so many individuals who contribute scientifically, and we're going to have clinicians on the team who follow the patients. But it's going to be small. We call that a small trial. And then what's going to happen is that once we run that and we show some interesting results, we're going to now say, okay, this calls for a multi-site trials. This is where we're going to, with colleagues. So I work with colleagues in Mayo and in Toronto who are doing something, particularly the colleagues in Mayo who just put in something for NIH to do something similar with a focus on suicide in youth. So our plan in the future is to pair up and hopefully do something like that across the borders.
So is there, how can we get some subjects into this trial?
So back to the other question. So once we're up and running, we're going to, hopefully you're going to hear from us if we do a good job in advertisement. So we're going to put advertisement around. There are going to be inclusion-exclusion criteria, obviously. And typically with these kind of trials, we kind of have to have some inclusion, but our understanding with youth is that it's hard to, that population has a lot of comorbidity with it. So we have usually kept it loose with the previous two trials. So we're going to probably keep it loose. But you're going to hear from us. So we're going to advertise it everywhere heavily once we have all the logistics in place. Yes, we will have.
So we'll go over here, and then there's someone over there, and we'll just take maybe 3-4 more questions before we wrap it up. Right over here.
Thank you. Hello. I have a question specifically about addiction. Have you done any trials of TMS with the addicted youth? And do you see any hope for this treatment to help with obsession and compulsion? I'm talking, yeah, I've read a book, Carol Lewis, of Biology of Desire. Sorry.
Right. So, yes, I do follow that work a lot. So my colleagues and friends at NIDA, the National Institute for Drug in States, they've run some trials, and the results of which I think is about to be published. And they show that, yes, when you do certain patterns of stimulation with TMS to the right brain regions, you do reduce the cravings for cocaine, for instance, in individuals who are going through addiction recovery. Now, how persistent the changes are going to be following the treatment is something to be seen. So there are works being done in that in that area that are promising. For OCD, I'm less aware of what's happening in that area, but I know of colleagues who've been trying it now. I cannot fully code or know what the results are, but I know people are trying it.
How can I look for the results of that trial?
For the night, I'm not sure if it's published yet, but I can link you to the names that you can look out for to see when that publication comes out. I know that I've seen it presented at conferences, but usually it takes time for it to come out.
We'll go over here, and then maybe just one or two final questions. Yeah, over here.
So, Doctor, thank you very much for an interesting and educational and insightful presentation. But we know historically electrical stimulation of the brain has existed for decades, even in the Hollywood movies. So, my question is, what was the spark, pardon the pun, that got you into this specific minutiae area, as opposed to hundreds of or thousands of doctors in the past that have fiddled with the brain and have come up with nothing that's even close to what you're talking about?
Right. I think there are several elements here. It's true that people have tried. I created a neuromodulation course in SFU in which for pretty much 3 hours, I go over all the history and how, it picked up in some years and then it kind of died out because people were misusing it actually at some point for showmanship, the Galvani's nephew being one of them. So I think what has made really the change is the precision. Right, so with what I showed you here, by combining all these modalities with a concurrency, like it's hard to do that technologically. So what I maybe should mention is that TMS is a powerful magnet. So, and its intensity is half of an MRI machine. Imagine the giant MRI machine. So that's how giant and how powerful the TMS is. Now, your brain waves are very, very tiny, are extremely small and fragile. So this combination, to make this possible, it just happened very recently, and we were able to do this both from the processing of the signal and being able to actually measure the brain meaningfully. And I think this has and also then combine that with functional MRI, be able to look at brain networks, how the brain, different parts of the brain are active during different tasks. So this combination and this multimodality of things has given this line of work it brought it to another level, where we can now actually go in and look at the brain like a circuit, which is dynamic and is plastic and is changing, and we need all these sophisticated tools to look at that. And really the excitement really built like that. And we have seen actually, and I think this is in part the enthusiasm that people want more and more to have these kind of labs set up. Not only just to do mental health research, like a lot of these setups are being just used for basic science research. And we do some of that work in my lab too. So there are times that we're just curious about how certain behaviors happen. For instance, inhibition control, impulsivity. What makes you make that bad decision? And if you carefully design behavioral manipulation and look at the brain at the same time and stimulate the circuitries, you see interesting results. And that has really been the driver of being excited by this. And also, I think that the brain that we are born with, this is a generation where we're now more focused on here. We want to control it. I'm not sure if some of you may have read the books that are written on that recently, but really we're now being more in control of how healthy our brain is, about how we can also harness its power toward the direction and treat it and augment it. And so that has been really the motivation factor.
Thank you. Just to distance yourself from those mad scientists in the sci-fi movies, that was a very important answer. We'll go for one last question up here. Yeah.
Hello. So I was quite interested in the machine learning that you spoke about to predict the treatments that might work for someone. I had a couple questions about that. Does that just rely on ECG and brain imaging, or is that possible to do with like the depression index or the stuff that you can kind of just do
Great
one-on-one?
question. Yeah. So here I just showed you one technology just to keep it simple, but you're quite right. It's quite possible to combine and bring in other signatures and combine it with EEG to have a better result. Have we shown that yet? No. Are we thinking that way? Yes. So far EEG, and I think this is why there's a bit of an excitement. So when we published that paper in January, right after, 2 weeks after that, a paper came from Stanford pretty much suggesting the same thing, that EEG can be used, and it's EEG alone. And I know of other efforts that are going on combining things, particularly with MRI, which it's not as portable and it has not really come out yet. So I think there's something unique about EEG. So there's some promise there, but we're very interested in combining it with other markers for improving its accuracy if possible. Yes.
All right, well, thank you very much, Faranak. That's wonderful to have been able to hear from you, and obviously there's a lot of interest in the room, and I'm sure a lot of interest more broadly. It's great to be able to share with you the knowledge of some of our researchers, and I think we've been really privileged this evening to hear from a researcher who is very much at the cutting edge with national and global reach. So please join with me in thanking Faranak for a really fabulous presentation. You want to sit down now? Now, Faranak has kindly agreed to stay behind because there will be a modest reception. Modest in terms of the food, not in terms of the conversation. And Arnav, you can tell me where the reception is, because I'm not sure. Is it out here? Out in the hallway out here. So just feel free to gravitate there as soon as we're done, which we will be in a second. I do want to thank the SFU Public Square team who've helped to put on this evening's event. Maybe you could join with me in expressing our appreciation to them. We have a lot of volunteers who are helping out along with staff, so thanks to them. And finally, I want to encourage you to check out the SFU Public Square website, because there's a whole bunch of activities coming up, including our annual Community Summit, which will focus on inequality, and over 10 days we'll look at aspects of inequality and what strategies there are to try to lessen inequality in society and overcome some of the deleterious effects that flow from inequality in our society. We also will have the final lecture in this series taking place in Burnaby at the Shabbolt Center for the Arts, a very different topic from one of our English professors, Dr. Paul Boudra, who teaches Shakespeare and early modern literature at SFU, and he's going to give a lecture on the Shakespeare conspiracy. So that promises also to be fascinating, and I encourage you to come out to the Shabbolt Center for the Arts to enjoy that as well. So thank you again for coming out this evening. Please do stay for the reception and join us not only for Public Square events, but for other events here at our Surrey campus, or indeed at our Vancouver or Burnaby campuses as well. Thanks so very much.